you for the chance of being here and presenting the slides. So what I'm trying to do today is comparing two very different approach to create scalable and message-driven application, both using Java, both backend application, but one using Spring Boot and being a microservice distributed application, and the other one using Akka, the framework by TypeSafe, now Lightband. These are very different. My comparison will start from one point, the reactive principle. So I'm comparing these two different approach from the reactive principle. So what's reactive? Unfortunately, reactive is one of the most semantically overloaded term in IT. So going beyond the definition from the dictionary, actually reactive means a lot of things, a lot of thinly related things. Just to give some example, it actually means more than this. So reactive is sometimes supposed to be responsive, especially for the UI. So it means quickly prompt to the user actions. Or reactive could mean data binding. So even not digging into functional programming, we can see one very simple example of data binding, of reactive approach, just in spreadsheet when we define a function. So we don't have a fixed value of one cell. We are just defining the function that the cell have to take. The value depends on the context and when it's valued. Reactive also means reactive streams or asynchronous data streams. It's a different field. Or also reactive in the sense of the Reactive Manifesto. That's the sense I would focus on. So the principle defined in the Reactive Manifesto. So what the Reactive Manifesto says, it states 4 main points. They are very generic as in every manifesto. 4 points. They are actually 3 requirements and 1 solution. So, first requirement, be responsive, oversimplifying, attain low latency in your application. Be resilient, simplifying, stay responsive on failure. So, even when failure happens, your application have to stay responsive, not to block. Be elastic, so be able to scale as needed, possibly linearly. And the 4th point is actually the solution on how to attain this 3 requirement is be message-driven. So use asynchronous messages as the only communication between your components. Okay, these are very, very generic points that could be applied from different point of view. So what Reactive Manifesto promotes? No blocking operation, no synchronization, no resource hogging, and decoupling and isolation both in time, so allowing concurrency, and in space, so components can be moved around and being everywhere. So your application shouldn't rely on the fact that one component is there, is at that responded data IP is in that instance of class. So we may face the reactive principle from different point of view. Roughly, we may face them from a top-down approach, say from macro, in a microservice terms, that means from at microservice boundaries, so at service boundaries. What does it mean? It means using message-based communication between our services, between our microservice, attain isolation at service level, but this is actually one of the points of using microservice, or from a bottom-up approach, from micro, so inside, within a service, within a microservice, at code level, a programming model, using message-based communication between components inside the service, using non-blocking processing, enforcing isolation at component level, not only at service level. Both this way could actually point exactly to the same reactive principle. So this comparison is based on two real projects we worked on. I was able to work on here in OpenCredo. One was using the Akka framework for a banking group, was a POC, and another one was a microservice application based on Spring Boot for a logistics company. Well, even if Akka shouts itself as being reactive, they also have a banner on their website. We are reactive in the corners. A bit funny. I would say we could actually attain some of the principle, maybe not all, but some of the reactive principle, even using a different technology that is not supposed to be reactive by definition. I know this comparison is very daring. It's very hard, as we are comparing apple and oranges. These are two totally different approaches, as I will see. Actually, in Italian, we don't say apple and oranges. We say apple and pears. So maybe I tend to see more the similarities in the difference than just the differences. So have a really quick look at some of the points of this application, what we did, what we are doing in these two applications. So the Spring Boot one. We used message-based communication between the service. Of course, we were differently constrained in the communication outside of the application. So we have to define an API, different API, not message-based, but within the application, between the services, we used message-based communication of RabbitMQ in this case, or anyhow, messages. We try to be non-blocking, at least where possible. So we deeply used Java 8 completable features inside the code. We use, for example, HTTP non-blocking servlet when we have to implement HTTP endpoint that are synchronous by definition. We use kind of fast returning API endpoint just to avoid to block, even if API, I mean HTTP, sorry, it's implicit, even if we have to block for the response. Interestingly enough, we used event sourcing persistence, using what was the forerunner of the concurrent framework Dom is going to present later. And all the application was wired up using Spring Boot specifically, and Spring Cloud features, Spring Cloud config for distributing configuration and so on. What about the Akka application? One interesting point, the Akka application was in Java, not in Scala. This is important. So both the application were in Java. Akka, sorry for who doesn't know it, is a framework that hasn't been developed by TypeSafe, but it's now promoted and maintained by TypeSafe, and has been mainly written in Scala, but also have a Java interface. So both applications were in Java. We were using Akka. We were using a cluster, an Akka cluster, that is a specific feature of Akka. Why Akka? Akka allowed us to use the actor programming model. A few words about that later. We used, actually, we weren't able to use as it was a short POC, but it was in the plan. We used event sourcing persistence that is provided by Akka out of the box. We use the Akka cluster to communicate, to enable the node to communicate each other. And we deployed all the nodes using Conductor, that is actually the only commercial product in the stack, as Akka is open source. We use Akka HTTP server when you have to expose HTTP API. This is a proprietary implementation of API, not proprietary, is an implementation of HTTP server, not based on any embedded server. So we have no container, no embedded Tonka, no embedded Jetty. And that is no blocking by definition. And all the things were configured using type-safe config. That is a open source config library in Java that could be used by any application, actually, not only in Akka. We haven't used the new Lagon framework by TypeSafe that is commercial, I think. I'm not sure. It's not open source. We haven't used the Akka streams that could have brought our abstraction one level up. But yeah, we decided to use the actor programming model and not the streams. So I assume most of the people here are kind of familiar with Spring Boot, microservice architecture, so I'm not spending any time for explaining anything about that. But I expect many of you are not familiar with the actor model, or Akka. So I'm spending a few slides trying to, well, not explain, would take hours to explain the actor model, but just to introduce the actor model. The actor model is not a new thing. It's been introduced in 1973 by the research article by this guy, Carl Hewitt. As many implementation, the most famous one probably is by the Erlang language in 1986 that has been created by Ericsson and then open sourced. It's probably the most famous language that is strongly based on actor model. The Akka framework itself started in 2009, so it's not new. It's written in Scala, as I told you, but as a Java interface. The Java interface is sometimes little behind the Scala one, but it's becoming usable. But what is actor model? Okay, I'm not going to read the definition from Wikipedia. I just would say it's a model for concurrent computation. So, actor model is a different way to attain concurrency. It's a programming model, it's not an architecture, so it's low level. What's the point? It's we attain concurrency using actors and not using threads. So our actor is the primary computational entity of our model. When you are working in Java, in Akka, for example, you are still in a mixed world of objects and actors. Actors in Akka are actually objects, Java objects. So, well, at first, to be honest, it was sometimes a bit confusing. Okay, this is an actor, this is an object, how could I interact? But it became very clear after a few days of working on it, the difference between what is an actor and what is an object. The most important point is that actors interact exclusively using asynchronous messages, as opposed to objects, Java objects, for example, that interacts calling methods. Methods are synchronous by definition. Okay, you make it asynchronous, returning completable future, whatever. In Java, at least, it's still a hack to have an asynchronous method. But when actor interacts sending a synchronous message, that interaction is purely asynchronous. Those actors react on receiving a message. They do nothing. They do not wait using a thread. They are loitering, not in a thread, and they wake up when they receive a message. There is no synchronization, and there is no lock. Why? As an actor handles exactly one message at a time. What does it mean? This is a very simple idea, but this means that the message handling code, the code that contains your business logic, that should be your focus, your value for the application, is intrinsically thread safe, it's single-threaded. So it's very simple. You don't have to worry about synchronization in that code. And this also means that your actor, even if you are working in a concurrent world, could have a simple state without any synchronization, as simple as a Java property. So an actor in Akka is an object, and the state of the actor could be a simple Java property without any special. Why? As your property your actor will never handle two messages at a time, so just one at a time is processed, so you have no concurrency problem in the message handling code. This very simple idea is very powerful. Also, an actor is very lightweight, so there is a little overhead when you are creating an actor over simply creating an object. Of course, there is something more than just creating a new object, but not so much. So you may not worry about creating a new actor when you need it. And this drives you to implement patterns, like, for example, having an actor instance per request, holding the request context inside the actors as simple instance property. This makes all the logic very, very simple. And this is not heavyweight. You may have, I said request, but could be a long-running transaction or whatever. Another very important concept in actor model is supervision. What supervision? Where supervision come from? Well, actors have collaborators. When you send a message, this message is never broadcasted. It's always sent to one target, to one actor. So one actor have to know its target. The actors have to send the message too. So that these actors are actually the first actors' collaborators. But how do you pass around these collaborators? It's very different from the dependency injection we are used in, for example, in Spring. We are not passing around object ref. We are passing around what is called, at least in Akka, but I think every implementation of actor have the same concept, an actor ref. The difference is an actor ref is location transparent, so that actor could be anywhere, could be in a different node, could be remote, local, whatever. It's life cycle transparent. The actor behind that actor ref could be restarted, and you are not affected. Your actor ref is still valid, and it's fully serializable, so it could be transmitted over the wire. So you may include it into the message freely without any risk. It's not like sending around an object ref that, of course, is going to break somewhere. Not talking about if you are remoting any service, you cannot send around object. So, supervision. Let me get back to supervision. So, as actors are created by the other actors, we implicitly create a parent-child relation, a parent-child hierarchy. This hierarchy is called supervision hierarchy, as it is used for failure handling. What does it mean? It means that the parent of an actor is always implicitly notified when one of his children fails. So the responsibility of handling failures is delegated to the supervision hierarchy. And this is orthogonal to the business logic, to the message processing logic that is implemented elsewhere. So you could actively easily separate the failure handling logic from the error handling logic, meaning failure, the unexpected condition, and error, the expected condition, say using input error, format error, whatever, something you may usually solve or have to reply to consistently. This way, failure handling is handled in a separate place. Have a look just at a few examples about how the reactive principle could be implemented in the plain Java application or Spring Boot application or in Akka from the 2 point of view. So macro, top down, and micro, bottom up. Sorry. We said we have to be no blocking, so never block threads waiting for some kind of response, some resource, someone else returning a response or whatever. Well, our macro approach is, well, as we did, using asynchronous messaging between services. So not using synchronous messaging for communicating between services, but using asynchronous message broker, whatever. A micro approach is different if you are using plain Java Spring Boot, or Akka. Using Java at micro, so inside your code, you can use completable future. You can use, it's just an example, no blocking servlet, not blocking HTTP servlet. You can use, if you really want to hurt yourself, you can use the low-level non-blocking I/O, Java non-blocking I/O. I wouldn't do that, but yeah. In Akka, you don't have to do much. as actually react to messages, so they never block waiting. They never block waiting for a message. They intrinsically sleep, not sleep in sense of making the thread sleep. They do nothing while waiting for a message. Still, we have to say, you have to use some discipline not to block inside the message handling when you are implementing your message handling logic and, for example, waiting for an external synchronous resource. Don't know, you are calling it a database, you are calling a legacy service that is synchronous by definition. You have to use some discipline not to block. But there are very easy patterns to avoid it. Sometimes it's just wrapping in a completable futures and piping it to as a message to another actor, and this means that the framework will take care of it and notify the other actors when the operation is complete. So you still have to apply some discipline, but it's not so hard. Handling timeout. Well, timeouts are often forgotten while developing application, and they are so important for resiliency. Where are timeouts at macro level, so at service boundary? They are on outbound connection, so when our service connect as a client to another service or another resource, or inbound request response or request ACK handling. For example, when we act as a server, we should handle timeout for the ACK or the response coming back and be sent to our client. At micro level, in plain Java, there is no consistent way of applying or enforcing timeouts. It's up to the developer. And what happens is actually they are unhandled, or more usually, we're using the default. So we have random timeout around, generating random bugs that they are very hard to debug. They are very hard to troubleshoot. In Akka, everything has an explicit timeout. So the developer cannot forget to apply the timeout. I have to stop and think about the timeout. This is simple, but it's enough not to have stupid bug generated by the timeout, but not handling the timeout, but not setting the timeout. Failure handling. When you are working asynchronously, it's sometimes tricky to handle failure. In Java, we are speaking at micro level. In this case, you have to do it handling, for example, in completable future, we have to handle the exceptional completion of the completable future. Okay, it's doable, but honestly, it's very error prone, easy to be forgotten, and also there is no proper way to separate the error handling, expected error, expected condition, from the failure handling. They are handled in the same place. It's very hard, and it's not very readable, to be honest, and it's very easy to make mistake. When using actors, failure is handled by supervision. You don't have to do nothing. I mean, there is a default supervision strategy that sometimes work without doing anything, but you may implement your own supervision strategy. The errors are handled as part of your message processing logic. So you grab the exceptional condition due to, parsing errors, for example, inside the message handling logic and return an appropriate response, and forgot in your message handling processing about any other source of exception and delegate the handling to the supervision. One word about the just one word about the event sourcing. So event or command sourcing is a natural persistent pattern for this kind of application, so for distributed asynchronous application. In plain Java, in Spring, you have no help. You have to invent your own event sourcing, and you may use concurrences. In Akka, actually, it comes out of the box as the Akka processes implement command in event sourcing. Why? As event sourcing naturally fits actors. I'm skipping it, not too into detail, but this come out of the box. Event sourcings, well, there are many videos about that. I would suggest some of the video, but never mind, sorry. So, get to a few conclusions. Reactive principle. I would suggest to keep in mind the reactive principle even when you are not using a technology that shouts itself as being reactive. They are, to be honest, very instructive. And they have more implication than the one you first think about when reading just the very first simple statement of the manifesto. They are very important to allow your application to be more scalable and resilient. So, does Akka or a framework like that help to implement reactive principle? Well, at micro, so inside our code, inside our service, I would say yes. It makes much simpler, more testable concurrent code. We are speaking about concurrent code, not simple Java code. Make much simpler. Require far less discipline than the plain Java 8 concurrent code. Still, it's a new programming model to learn, so it have a learning curve. Also, I would say another point, it's very low level, so the bricks are very small, and you have to build many bricks. This would be different using reactive streams or Akka streams, but for this project we use the actor model, so the low-level approach. Does Akka help at macro? Doesn't make much difference, to be honest. You still have to apply a lot of discipline at architectural level, so designing your interfaces between the services. Also, I would say Akka force you to reinvent a lot of wheels when you have to integrate with the external system. Doesn't provide the same level of help of Spring ecosystem. And unfortunately, Akka doesn't integrate with Spring. So you cannot use Spring and Akka. They are really, in this case, apple and oranges. That you cannot put them together. Well, so why not using Akka or say actor model and microservice? They are not mutually exclusive. I would seriously consider in a wide microservice application, so having many microservices maybe developed by different teams, adopting Akka for some of the services. There is no point of not doing that. I mean, there's no real problem in doing that. Maybe for the most business critical one, maybe for the services that need to be more resilient. And to be honest, I saw it is far easier to make a service more resilient using Akka than using the plain Spring approach. Or in the services that require the higher concurrency level. It's much easier to attain highest concurrency, high throughput using Akka than using Finish. Well, I finished. These are just a few links. If someone is interested into, I just would say not stop to the Reactive Manifesto homepage. Read the glossary. You will find out some simple concepts, but could be interesting. Well, any question? I think we don't have any time. Okay. Yep. And I'm sorry, I don't know the other library. I never used. So for sure, there is not only Akka for implementing actor model. Maybe it's one of the most used in Scala, Java world, but it's not the only one. I'm sorry, but I don't know other libraries, so I'm not able to do comparison. Maybe other libraries are better from Cypress. Different approach. So there are other approaches to concurrency, but it's a different one. Yeah, actually, the question was about the integration. I said the integration is very poor. Akka integrates a camel integration. This is true. The point is they put something very different into Akka. So camel use a very different model for approaching the concurrency. So you are not able to use it effectively in many cases. Just to give you an example, we had to implement SOAP endpoint, legacy company. SOAP endpoint, be server of SOAP endpoints, and Akka provides nothing out of the box. So first idea, okay, let's use Camel. Well, Camel use its own separate container to bring up everything, his own marshalling system, so you end up losing any advantage of using actors and, well, the different concurrent model. So we have to re-implement ourselves that point. Based on Akka HTTP server, this is out of the box, but all the SOAP things have to be rewritten. This is just an example. So the Camel is useful, but limited, to be honest. Yep. There's an example. I suspect it will be mostly the same with other integration. Yep.
Sorry, we've got Thanks so much, Lorenzo.
Thank you.